Okay, hi everyone, how are you all doing? Today we have another Codeforces round and it is a div 3 round, so it won't be rated for me. Now, the great part about unrated rounds is that I get to talk more. I don't have to think much about the rating. So, yeah. Also, for anybody that is just starting out in CP, I think div 3 rounds are just perfect. Uh, you don't get demotivated because you most likely will be able to solve the first two problems. But when you compare it to a div 2 contest, you might not even be able to solve the first problem. So yeah, div 3 rounds are great, and let us just begin now. Okay, the elections in which three candidates participated have recently ended. The first candidate received A votes, the second received B, and the third received C. For each candidate, solve the following problem: how many votes should be added to this candidate so that he wins the election? That is, the number of votes for this candidate was strictly greater than the number of votes for any other candidate. Each candidate, it is necessary to solve the problem independently. Okay, so all you have to do is just subtract the maximum, right, from this. Fine. Okay, see out max of, let's just take a variable. See out max one, and let's just do a plus one because that is what we will need here. But why a plus one? If the maximum is already greater, okay. Okay. So if A is we want the highest votes. So the highest votes should be okay. Now if more than two candidates have this maximum, then we need max one plus one, right? Okay. So here we need right. Okay. So for A, I just have to compare it to B and C, right? So int val1 equals to max of B comma C plus 1. C out val1 minus A int val2 equals to max of A comma C plus 1. C out val2 minus B and we have int val3 equals to max of B comma A. C out val3 minus C. Yeah, I think this should be fine. Okay, it is taking up a lot of time. We have 1, 1, 1. 66 minus 59. Okay, so this has to be this. Okay, 111 66 061 550. Cool. This seems fine. Cool. So looking at the second problem, it is given a positive integer n. In one move, you can select any single digit and remove it. Okay. Some position in the number and removes the digit located at this position. The operation cannot be performed if only one digit remains. If the resulting number contains leading zeros, they are automatically removed. Leading zeros. Fine, fine, fine. If one removes the third digit, then this will become 3225. Fine. Now, if we remove 2, then the leading digits will be removed. Fine. What is the minimum number of steps to get a number such that it is divisible by 25 and positive? It is guaranteed that that for each n occurring in the input, the answer exists. Okay. Fine. Minimum number of steps required. So this has to be a multiple of 25. Then what are the multiples of 25? We have 25, 125, 625, 3125. All of them have 25 at the end. Do they have 25 at the end? Yes, because if you have 25 at the end and you multiply it with 25, then okay, no. This has to be a multiple of 25. So it can be 25, 50, 75, anything like that. Cool. So if we have 18 digits we have here. And there is at least one number which we can form, which is divisible by 25. Okay. Okay, will we ever have to remove more than 3 digits? That is a question here. Yes, we might have to remove more than 3 digits. Fine. Multiples of 25. Is there some property in the multiples of 25? So basically, if you look at it, there can be a lot of multiples of 25. But it has to be some subset, some subsequence basically. Right, it has to be some subsequence of the given number. Okay, if we have two zeros, then you're done, right? If we have two zeros here. That is one condition, fine. Okay, if we just look at the last two digits of a number, they can be either 25, 50, 75, or 00. These are the only four types that we can have for the last two digits. Fine. So if I can just select two digits of this form, 25, 50, 75, or like 00, then I can remove all the other digits. Now, how will I remove all the other digits? That is a question again. The last two digits have to be a multiple of 25 basically, right? So all the digits to the right will get removed for sure. And if you talk about the digits to the left, I mean, we don't really care about the digits to the left. We only have to remove digits in between. I think this is fine. All we have to do is run like an n square type of a loop, or instead we can do it like a string. So we have this. Fine. So this is the part where I'm generating this number, and I'll just check if this is a multiple of 25 or not. Cool. So if val modulo 25 equals to 0, then I just do. So I'm considering the jth index and I'm considering the ith index. So I have to remove digits in between, right? So that will be j minus I minus 1. Answer comma j minus I minus 1 plus we'll be also removing all the digits towards the right of j. So that will be n minus 1 minus j. Zero 3 1 3 2. Yeah, this is fine. Let's submit this. Cool. Let's move to the third problem. Okay, D1 has more summations than C. Let's just see who all have solved this. Okay. I think both of them should be solvable. Anyway, let's just look at C for now. Right. So there are one cat. There is one cat, k mice, and one hole on a coordinate line. The cat is located at the point 0. The hole is located at the point n. Okay. All mice are located between the cat and the hole. The ith mouse is located at the point xi. At each point, many mice can be located. In 1 second, the following happens. First, exactly one mouse moves to the right by 1. If the mouse reaches the hole, it hides. That is, the mouse will not anymore move to any point and will not be eaten by the cat. Then after that, the mouse has finished. Then the cat moves to the right by 1. If at the new cat's position some mice are located, the cat eats them. They will not be able to move after that. The actions are performed until any mouse hasn't been hidden or isn't eaten. Okay. In other words, the first move is made by a mouse. If the mouse has reached the hole, it's saved. Then the cat makes a move. The cat eats the mice located at the point at the pointed Okay, this problem statement has some terrible English here. But anyway, has reached the cat has reached the hole, it eats nobody. You can select a mouse that will make a move. What is the maximum number of mouse? Okay, fine. So we have to save the maximum number of mice here. Cool. And we're also given these positions where the mice are located. Fine. Okay. So only one of the mouse moves here. That is something to be taken into account. Okay. First of all, I need to sort these values, like wherever they are placed, I need to sort them. That is one thing. Then I have to decide which of these mice do I need to consider. Okay. Now, obviously, if you look at the last mouse, why should I not want to, consider that mouse, right? And if I am considering that mouse, then why should I consider it at the very start? I should be considering the mice towards the left side first, in order to save them. So I can define like which mice do I want to save. For example, if I want to save the ith mouse, then it just makes sense to pick up the mouse. Um, Also, can I do a binary search here? If I want to save 5 mouse, let's say, I will be saving the last 5 mouse. Why would I be saving the first 5 or the middle 5 mouse? That is pretty intuitive. So, okay, just a minute. I hope everything is fine. Okay. So if I can do a binary search here, obviously, and if I'm saying that I want to save 5 mice, then I need to pick the last 5 mice. Okay, then how would I simulate this part? So I will pick the first mice at the end. And I can reach it, I mean, I can shift it towards the other mouse. That is something that I can do. Fine. After that, so for this part, I just need one time. Like if I have to move 5 places, I just need 5 seconds. But if I have 2 mouse at the same point, now in order to move them, I will need 10 seconds. If I have to move them 5 places. Okay. Fine. I think this can be simulated. So what I'll be doing is this. I mean, since the round is not rated for me, I don't really care about the penalty that I will be having. So this is what I'm thinking of doing here. If this is the array of mice, then let's say I am picking up these mice and I want to save them. Okay, so if the cat is here initially, then first of all my first mouse will be moving here, right? I will be moving this leftmost mouse because that is the greedy part, right? I mean, I'm not explaining why are we picking the leftmost mouse, because, or I mean, if I have to explain it, why would you pick up this mouse when the cat can eat this mouse first, right? So basically I will move this mouse to here, and if this is like 5 places, I will be moving 5 places here. So the cat will move after 5 places here. Okay. Now when I reach here, I have 2 mice here, and let's say this place is 6, like the distance is 6. So I will be requiring 12 seconds here. Okay. So I'll see where does the cat move after 12 seconds. Fine. Uh, if the cat moves here, yeah, so basically the cat should be one place behind. That is exactly what you want. Okay, and at the end we just see if we can reach here or not. Fine. So I think this can be simulated. Yeah, let's just do this. So I have n and k. Fine. So I'll be needing this vector. Right. So I'll be doing this. LL end equals to k. Like if we are, this is like the binary search part. If I'm saving one mouse or am I saving like k mouse here? Obviously, one mouse can be saved at all times. Okay. So okay. So if helper, this is the part which will tell me if it is possible or not. I'll pass this mid. I'll pass this ARR. I'll pass n here. Right. Yeah, this should be fine. Then I just do what? I do this. Fine, now I have to simulate this. So this will be like a Boolean function. Fine. So I have to pick the last k, I mean the last two save mouse here. So I'll be, I mean, do I need a vector here? Since this is order of n, I can obviously create a vector. I is less than 2 save I plus plus, and I'll just do this here dot pb arr at n minus I minus 1, and I'll also reverse this. Fine. Now I have to see where my cat position ll cat equals to 0, ll current equals to 0. So I'll also put this n value here dot pb here dot pbn, right, and this has to be s set of arr. Fine. Now okay, while current is less than okay, now we have to see how many mouse we have taken already. So taken equals to 1. Okay, distance equal, the distance that you have to travel is here at current plus 1 and minus here at, so this is the time that will be required here, right? Now if distance into taken, I mean this is the time that we require. If distance into taken is greater than minus cat, then this is possible, right? So I'll do taken plus plus, and I'll do cat plus equals to distance into taken, right? And else we just return false because that is not possible. So taken is the number of mouse that we've taken till now. Distance is the distance that we have to travel from one point to the other. Now this is the time that will be required, distance into taken. If it is less, right? If it is less than here of current plus 1 minus cat, also I have to do current plus plus, and at the end I just return this if sorry, here dot back minus here of input taken is less than equal to minus cat. This is what I'll be returning. Fine. Let's see. So I have 2 and 2. Now this should have been 3. Okay, let's just debug this. And let us consider it for just one case here. And also let's debug here. I think this has to be here minus 2. No, this is fine. Also we need to debug so I have 4, 4, 5, 7, 8, 9, which is fine. We want to save 2 elements here. So we want to save 3, so we want to have 7, 8 and 9, right? So we have ARR. Okay, this was 1, this was not I, this was 1. So we have 7, 8, 9, 10. Now, if we want to save 3, then debug cat. Okay, so it turns out that we are not even able to reach this part. No, we are able to reach, we went to 9 here. So from 7 to 8, this required 1 second. From 8 to 9, this required 2 seconds. From 9 to 10, it will require 3 seconds. Why do we have taken equals to 4 here? Okay, let's also debug this part. Debug cat, debug empty taken. Right, so initially we have cat equals to 2, but the distance is 1, right? This had to be here. Now will the taken be 4 or will it be 3? So initially it is 1, we reach here. Now it becomes 2, we reach here. Now it should become 3, right? Why are we having this as 4? No, cat is at 1 after this. Taken is at 2 because now we have to shift 2 elements. Right. Then cat is at 3, fine. Now cat is at 6. Initially we have to move 1 point, then we have. Why is it running for 3 times? This has to be minus 2, right? So we have taken is 3 finally. Cool. I think this is fine now. Okay, now we're having 3, 2, and 4. Can't we save 2 elements here? So all of them are at 1. Okay, so the cat will eat them up. That is also the thing, right? Okay, let's do it for this part. How am I having 2 here? So cat is at 0, taken is 4. Cat is at 0, taken is 2. Can it be equal? I don't think it can be equal. No, it cannot be equal. If we have anything greater than 1, this cannot be equal. Right, so the initial answer has to be 1. We have to start with 2. Okay, 3, 1, 4, let's submit this. Cool. So let's move to D1. This was a good problem, binary search. 881 submissions on D1. Yeah, this should be doable. This problem is a simplified version of D2, but it has significant differences. So read the whole statement. Okay. Polycarp has an array of n integers, a1, a2, so on up till an. Polycarp conceived of a positive integer k. After that, Polycarp began performing the following operations on the array. Take an index I and reduce the number ai by k. After Polycarp performed some number of operations, it turned out that all the numbers in the array became the same. Find the maximum k at which such a situation is possible. Or print -1 if such a k can be arbitrarily large. Arbitrarily large. Okay. So we want to make all of these numbers same, right? Yes. So we can write it something like this. Okay, let's make a new page here. So if we have these elements, we have a1, we have a2, so on up till an. Now this will be transformed to something like this: a1 minus t1 times k. Then this will be transformed to a2 minus t2 times k, so on, and this will be transformed to an minus tn times k. Okay, fine. Now if you look at any two of these numbers, like this should be also, we have n is 40. Fine. So let's say I just consider these two numbers a1 and an. Okay. So after I do this, this is what I want: a1 minus t1 times k to be equal to a2 minus let's consider a1 and a2 minus t2 times k. Okay. So we have a1 minus a2, that should be equal to t1 minus t2 times k. Right. So the condition that we want here is that a1 minus a2 should be congruent to k. Right. Yes, we want this condition to hold. A1 minus A2 should be congruent to 0 modulo k basically. So this is what we want here. What are the number of test cases that we have? Only 10. So let me just write it here. Right. So this is the condition that we want here. We want A1 minus A2. Okay. This should be congruent to, let me put it like equal to 0 mod k. Fine. Again, we want A1 minus A3 to be congruent to 0 modulo k. Right. So we will be having a lot of such equations. Now, we need to decide what is the maximum k. Right. Fine. So can I just take the GCD here of all these differences? If the GCD comes out to be 0, then I mean, yeah, you can have an arbitrary large k. Yeah, this should be fine. We can keep it like this only. Right, and after this, okay. So we have 2, 1, 1100, this is fine. Cool. So let's look at D2 now. Polycarp has an array A of n integers, that is fine. N is even now. Now Polycarp conceived of a positive integer. Fine. After Polycarp performed some number of operations, it turned out that at least half of the numbers in the array became the same. Okay. Fine. We want at least half of them to be same. Right. Okay, so the very first condition here is that if more than half of them are equal to some one number, then the answer is -1, right? Otherwise, if we just have to pick up a GCD, I can pick up any GCD here, right? And I can see if at least half of such numbers are valid here. No, but that won't be fine. Also, there is just one thing, okay? When we want at least half, why would we want to pick up more numbers? Like if we are picking up more numbers, the GCD is going to get reduced, right? So why not just pick up 20 numbers exactly? Right? So if I just have to pick up 20 numbers exactly, So maybe E is solvable. Yeah, I think maybe I should try out E now instead of D2. For this part, it is, I mean, I'm damn sure that I have to pick 20 numbers exactly. Sorry, I mean the half of n exactly. There is no point in picking a more numbers. But how should I choose these numbers? That is a question. Okay, also the condition here was this. We were doing this. A1 minus A2, then we have A2 minus, sorry, A1 minus A3. So on up till we have AN minus 1 minus AN, right? So when I'm considering the GCD, I am considering the GCD of this, like this is just one number. Now when I look at this A1 minus A3, I want to look at the GCD of this, GCD of A1 minus A2, comma, A1 minus A3, right? So if I'm looking at this part, I can just simply remove this A1, right? Can I or can I not? I mean, if you look at the GCD, it is nothing but this, like GCD of A comma B is equal to GCD of A comma B modulo A. So if I take the B modulo of A here, no, that won't work. Let me just see if there is some theorem about this. Or maybe let me just look at this problem once. If it seems doable, then I can do this one. A tree is an undirected graph, okay. It's about non-rooted trees. A leaf of a tree is a vertex that is connected to at most one vertex. Fine. He decided to trim the tree. To do this, he performs a number of operations. He removes all leaves of the tree. Okay, so this will remove, this will get removed, this. Okay, fine. So all the nodes with degree 1 will be getting removed. And when you do that, you are also updating the degree of other nodes. Fine. Note the special case of the operation. Applying an operation to an empty tree does not change it. Applying an operation to a tree of one vertex removes this vertex. This vertex is treated as a leaf. Applying an operation to a tree of two vertices removes both vertices. Fine. Vitally applied k operations sequentially. How many vertices remain? Okay. Isn't this like simple implementation? What is the issue here? Also, when I was looking at the standings, there were certain wrong submissions on this. Was it a TLE? What was it? No, I think this should be doable. Let's try out this one. Or let's have a set here. But how will I consider these nodes? I will have to constantly update them, right? So yeah, so if I can keep these nodes sorted according to the degree, right? Fine. Okay. Okay. Fine. Now all I will be doing is just I will be considering all those nodes that have a degree of uh, that have a degree equal to 1. Okay, but I will also have to no I can store a vector here. Star sorted dot begin dot ff equals to 1. I do 2 remove dot bb sorted dot begin dot ss. Right, so this is the node that will be removed here, and I'll also do sorted dot erase dot begin. Fine. After this, I do this. Edges at shape dot erase I. Now so I will be updating this value. Right, and here I'll do k minus minus. Sorted dot insert this. Okay. Sorted dot count. Edges at J, and we have J. Okay, what's the issue here? It's greater than 0. Sorted dot erase. I'm not sure what is the issue here. If sorted at sorted dot count edges at J, comma J. Now what is the issue here? This had to be said. Okay. Now I don't know why this is taking such a lot of time. Okay, this had to be n minus 1. Seven zero zero 30. Okay, this was one node is remaining here. Let's see. For this case, one node has to remain. Okay, let me just draw out this tree here. So we have 6 to 2, 6 to 5, 6 to 2, 6 to 5. Oh, sorry, this is 5 to 1. Sorry. This is 5 to 1. Then we have 5 to 2, we have 5 to 6, 2 to 4, 3 to 4. Okay. So after one operation, 1 is removed, 6 is removed, 3 is removed. Debug sorted. So we have 1, 3, 4, and 2. No, no, but which nodes are removed here? Sorted.begin.ff equals to 1. We have 5 to 1, 2 to 5, 5 to 6. Let's also debug this to remove. So we have 0, 2, and 5. 0, 2, and 5. Fine. After this, we have remaining 3 is remaining, 1 is remaining, and 5 is remaining, which is fine. It's less than equal to 1. I don't think this is required. Let's just keep it like this. Right, fine. Oh, okay, this went into an infinite loop. Just a minute. If we have two nodes, then both of them have to be removed. But why are we inserting it again? So when I do this, it goes into all the edges and it checks if it is already not in the removal list. Okay. This also has to be done. Okay, fine. This is fine now. Right, let's submit this now. This seems fine. Okay, so it took up a lot of time actually. What is the time limit here? Time limit is 4 seconds, so this should be fine. Okay, I think now we can try out D2. Fine. Also, I think for D1, it could have been done without binary search as well by maintaining suffix sum. Yeah, I think that could have been done as well. Okay, let's try out D2 then. So we want to pick exactly half numbers. Now, which numbers should we pick? That is the question. Should I read problem F? I am having no ideas for D2 till now. So maybe going for F can be a good idea. It is given a non-negative integer x, the decimal representation of which contains n digits. You need to color each of its digits red or black so that the number formed by the red digits is divisible by a. And the number formed by, okay, at least one digit must be colored in each of two colors. Consider the count of digits colored in red as R and the count of digits colored in black as B. Fine. Among all possible colorings of the given number x, you need to output any such that the value of R minus B is the minimum possible. Note that x and numbers formed by digits of each color may contain leading zeros. So that is fine, that we don't really care about. Can we define a DP here? Like if I say that I want to color, right, I can do it like this. That if I say I'm coloring R digits as red, then B is fixed, right? This B is fixed, this is n minus R. Fine. And what I can do is, I can do this. If I look at the first I values, right? So my DP of I comma R comma B comma mod 1 comma mod 2. This can be my DP state. Now, are there certain things that I can skip here? I can skip this B because B equals to R minus I, right? So this just tells me that, if I'm on the ith index, I have colored R digits as red, and B is basically R minus I. Should it be R minus I? Like if I'm at index I equals to 5, then there are basically 6 values here. And if I've colored 3 values, then 2 are remaining, right? Right, I think this is fine. B equals to R minus I. Right. So we have this. And we need to check if it is possible or not. Now mod can be 40, this can be 40, this can be 40, and this can be 40, right? So if I look at it, this is like into equals to 10, which is 1000. This is 2 into 10 to the power 7, which should be fine. This is just hard to implement because we also have to find this. So this DP state can store whether it is possible or not, and if it is possible, if it is possible, then should we insert an R here or a B here? So we can have a pair of DP, right? I think this can be done. And we also have 10 test cases. Okay, this can't really. This is because we have 40 to the power 4. Okay, so this was including that, right? So this is fine. Mm, 41. Also, let me just see if this is fine with 41 as well. One, two, three, four, five, six, seven. This is fine. Okay, n is also up till 40 only. So the thing is that we don't have 40 to the power 4, which we just have 2 here. Oh no, this is a string, right? So this is 40 to the power 4 only. Okay. And we can also have the string as global. We can even have n and a as b, n a and b as global. So the first part tells us whether it is calculated or not, and the second part tells us what do we choose. we can have a -1 here as well. Right. So we have helper. We are at the 0th index. We have picked up 0 R values. Current mod 1 is 0, mod 2 is 0. Right. After that, we just have to backtrack. So we have int index, int R, int mod 1, int mod 2. Right. Now, if index equals to n, then if mod 1 and mod 2, then you return r minus n. Right. Fine. Okay. Now, if dp at index comma r comma right, this is also fine. Now we have two choices. So now, so once we can insert an R here or we can insert a B here, right? So if we do an R here, so we have so we'll be having this index plus 1, R plus 1, mod 1 plus s at index plus 0 modulo a, and we have mod 2. Right. And for answer 2 we have this. So mod 1 will remain same, mod 2 plus s at plus 0 modulo b. Right, now if answer 1 is less than answer 2, then I do dp of index comma r comma answer 1 comma answer 2 equals to, sorry, this had to be mod 1 and mod 2. I have answer 1 comma, I am inserting an r here, right? So I can make it like a 0. Else dp at and I can have a 1 here. So here I'll be just returning this value. This just tells us what is our answer, right? Cool. Now if dp at 0 comma 0 comma 0 comma 0 is less than 1 is 6. If that is the case, then we backtrack, else we do -1. So how do we backtrack? We have our current index, r equals to 0, then we have mod 1 equals to 0 and mod 2 equals to 0, right? Now if dp at, also we have to do this while index is less than n. So if dp at index comma r comma 2 dot ss, if this is an r, then we do this. First we see out r, then we do mod 1 equals to mod 1 plus s at index plus 0 modulo a, and we do r plus plus. And at the end we do index plus plus. Right, let's see. Okay. Dot ff. This has to be dot ff. This also has to be dot ff. Okay, why am I always having a B here? So if you look at the first one, then we have B and R. Like if you look at the last one, let's look at the last one. Okay, in the last case, I'm having a minus on here. So S at index plus 0 modulo A, right? Okay, this had to be n minus R. Okay. So we have mod 1 equals to 5. How come we're having it as 5? We have n, A and B, right? Debug index debug. Okay, so when we have this is fine. Oh no, but we also have to consider the power of 10 here, right? So how do I consider the power of 10? So for that, first of all, I can reverse this. I can reverse S. Okay, and after that, the value is not S at index. Val1 equals to, we have to take the power of 10, right? So we have expo 10 comma R. R is the number of indices that we've used till now, and we have A plus S at index. Now this had to be multiplied, right? S at index plus 0. Okay, so this is why we needed a B here, right? B equals to index minus R. So we have this, and then we have A. Now we also added to the current mod. Okay. Fine. And similarly, we have a while to here. name it as B1. Right, so here we'll be passing mod2 only, and here we'll be passing val2, val1, and here we'll have val2. Fine. I is less than equal to n. Okay, we're still having this. So the mod 1 is coming out to be 5. How come it is coming out to be 5? We have 0 and 9. Fine. So we look at 0 first of all. And when we say that index is 1 and this is this, then mod 1 is coming out to be 5. How come mod 1 is coming out to be 5? This had to be minus, right? This had to be minus. Oh my god. So now I'm having a B and B. Fine. So I have 0 and 9, then I have mod 1 is this mod. Okay. So if I insert an R here in the starting, okay, this is what I have. Then this is what I have. Then I have 90 mod 7. 90 mod 7 will be, yeah, this will be 6, fine. Why am I getting a B and B? Oh, okay. So this is not n minus r, this is abs of, okay. B1 equals to n minus r, and we have okay, I'm still having this right. abs of B1 minus r. So when I have index 2, I want minimum, right? Yeah, I want minimum. So why am I having a BP? Okay, this had to be not a 1, this had to be 0. Right, now I just have to reverse this. Okay. Okay, I have BRR, and here I'm having a BBBB. Okay, I'm not sure if a BBBB works here. Okay, one of them has to be at least right. Okay, okay. So, okay, I'll just do this right. It's less than N basically. Wrong answer on test 2. Okay. Okay, let's just read the problem statement once again. Okay, so since I've reversed them, I'll be taking the power accordingly, right? So this is like 10 to the power R into this value, right? And val 2 is this. So if I'm using this as this one, then mod 1 will remain the same, but mod 2 will change to val 2. Fine. Okay, this was mod 2. This was mod 2. Now this is just insane. How am I having a BB here? This has to be less than N, right? How am I having a BB? Let's try it out just for one case. Okay, this is different. Okay, this is just different. So mod 1 has to be this, right? And mod 2 also has to be changed. Let's see if this is fine or not. Fine. Okay, I am glad I did not waste a lot of time on D2 and instead move to F. Okay, I'm not trying this out more. Like there are just 15 minutes left and it will take some time to implement as well. So I'll be ending the recording here and most probably I'll be doing a post-contest discussion for this. So if somebody is able to solve D2 on my server, I would love to have them, discuss this problem. But otherwise, I'll be just discussing the problems that I have been able to solve till now. Fine. So yeah, I'll be ending the recording now. I hope you all had a great time watching this.